Hey everyone, welcome back to my channel, where we dive into the world of coding and tackle some of the most challenging problems out there. Today, we're going to be talking about a medium-level problem on LeetCode called Count Subarrays with Majority Element I. This problem is all about finding the number of subarrays within a given array that have a majority element, which is a really interesting concept. So, let's get started and break down this problem. So, the problem statement is pretty straightforward. We're given an array of integers and a target element, and we need to find the number of subarrays within this array that have the target element as the majority element. Now, a majority element is an element that appears more than half the time in a subarray. This means that if we have a subarray of size 5, the majority element needs to appear at least 3 times in that subarray. Now, the core insight of this problem is to recognize that for a subarray to have a majority element, that element must appear more than half the time in the subarray. Think of it like a voting system, where each element in the subarray gets a vote, and the majority element is the one that gets more than half the votes. This intuition is crucial in solving this problem, as it allows us to focus on counting the occurrences of the target element in each subarray. A simple analogy to understand this is to imagine you're at a meeting with a group of friends, and you want to decide what to do for the day. If most of your friends want to go to the beach, then the beach is the majority decision. Similarly, in this problem, if the target element appears more than half the time in a subarray, it's the majority element. So, how do we apply this intuition to solve the problem? Well, we can start by iterating over the array and considering each element as a potential start of a subarray. Then, we can expand this subarray to the right and count the occurrences of the target element. If the target element appears more than half the time in this subarray, we increment our count of subarrays with the target as the majority element. We repeat this process for all possible subarrays, and at the end, we return the total count. Now, let's take a look at the C++ code that implements this approach. We start by initializing a variable count to store the number of subarrays with the target as the majority element. We also initialize a variable n to store the size of the input array. Then, we have 2 nested loops. The outer loop iterates over the array, and the inner loop expands the subarray to the right. Inside the inner loop, we check if the current element is equal to the target element. And if it is, we increment the target count. We then check if the target count is greater than half the size of the subarray. And if it is, we increment the count of subarrays with the target as the majority element. Finally, we return the total count. Now, let's talk about the time and space complexity of this solution. The time complexity is O(n squared), because we have 2 nested loops, each iterating over the array. The space complexity is O(1), because we only use a constant amount of space to store the count and target count variables, regardless of the input size. And that's it for today's problem. Guys, I hope you enjoyed this explanation and learned something new. If you have any questions or comments, please let me know in the section below. Don't forget to like the video, subscribe, and comment your approach below.